Pragmatic Bookshelf and Wiley Publications, and also the Internet Society, who provides videography and editing, helps us see that we can post videos of past presentations. We're producing a video. We'll see if it comes out well enough, and we, in the speaker agree, we're going to post it. We'll have this for a record that people who couldn't make it can see, and hopefully it will help the speaker also get more exposure to other potential speaking engagements. I just want to say membership in New York Spin is free. We're a member-driven and member-based organization. We are here to make programs that are of interest to you, so please join us by going to both join us as officially as a member of New York Spin by going to our website, newyorkspin.org, click become a member, and go to our meetup group, and join our meetup group as well, where you can get postings that are on the meetup, and you can interact with members more easily there through the networking tools they have there. We thank we have terrific pizza tonight. I want you to enjoy that. We're going to have we have 2 door prizes. We're going to pass around collect a bag to put your business cards in during the meeting or at the end. One will be a certificate from O'Reilly Media for a free ebook of your choosing. The second will be a book that our speaker tonight has recommended, The Master Algorithm. He says it's like the book. He said if there's any book to read on AI, artificial intelligence, that's the book he wants people to read. So we will raffle off a copy of that, and we will send it to you when we order it. Send it directly to your home. We won't have it here tonight. So that's only for people who are here through the bitter end. Stay for the end of that raffle. Okay. We had a speaker here who was a member, actually was a young practitioner in the field. He worked with Richard at Fiserv, and in 2012, Darren Drake spoke to us. Unfortunately, Darren Drake was one of the victims of the terrorist attack a few months ago on the West Side Highway, where someone drove a truck through a bicycle path. Unfortunately, he was instead of taking a break by eating a meal or going for a drink somewhere at work, he would take a break by riding his bike in the park. So we would just like to give Richard a chance to say a word or two about him. We'd like to have a moment of silence in his memory. And we encourage you to see the past presentation video of him at some point in your leisure. Richard?
Well, you pretty much told most of the story there. The presentation was actually November of 2013. And the title of the presentation was, Does Agile Help the Knowledge Worker? Just a little bit of quick background. I worked with Darren at Fiserv. At the time, he worked Fiserv with me at one point. He was at a different company when he was killed. And I actually had to kind of talk him into giving the presentation. He was a little reluctant at the time. And, but he did it. It was a big hit. It is available through our website. Again, it was November of 2013, so if you go to nyspin.org and just scroll down through the presentations, you'll see an actual video of the presentation. I actually wrote to his parents and sent them a link. His mother had actually attended that presentation. And that was the first public presentation I think he ever gave. So she's a proud mother sitting in the audience of, this was so tough. So if we could just have a moment of silence with him.
For our program tonight, our speaker has been a passionate technologist for over 20 years. In 2010, he founded his firm, Ahmadeus Technology Boutique, where he leads technology development for the 60 mobile apps and a number of proprietary enterprise systems they have delivered to clients in that short time, only since 2010. On their website, you could see links to some of these apps. Ahmadeus, this company, also provides R&D, MVP, product development, C-suite consulting, technology discovery, and advisory services. They work in disruptive technologies of blockchain, mobile, cloud computing, and artificial intelligence. Their client list reads like a who's who of the global companies and brands that we know in investments, money center banks, pharmaceuticals, and media. That's why he still has to wear suits to work, unfortunately. But I guess that big dry cleaning bill is a small price to pay. You may notice in his bio that he also says he likes to travel and likes exploring different cultures. Well, it so happened tonight in being here is actually an example of this, because as an ardent resident of the village, he says this is the first time in 20 years he's been north of 14th Street. So we're very grateful to him to stepping out of his comfort zone and joining us for tonight. If that's not getting out of your comfort zone, I don't know what is. So here is to fill us in on artificial intelligence. Let's give a warm welcome to Ahmad Alaghosh.
Thank you, everybody. I didn't say 20 years I've ever been at north of 14th Street. He was asking a question. I was saying I'd like to stay below 14th Street as much as I can. It's a different vibe. Union Square is like a dividing line for me. 23rd is another line. But I don't know. I feel like, I don't know, if you live in the city, you'll find people like this awkward. Anyway. So, my name in my language is Ahmed. I don't want people to have phlegm with it. So you can call me Ahmad. That's how I choose myself. So I call it Amadeus. As in Arabic, there's another letter. But anyway. Yes, I'm a programmer essentially. I used to work in financial services. I know one of the guys here used to work for Morgan Stanley, and I used to work for Morgan Stanley too. And up until 2008, we've done multiple projects. And when Lehman was about to collapse, human resources walked into our division in equity derivatives. I said, everybody get out. And they gave us severance package, and I realized after that, there has to be another way of working. I don't have to be just cut off like a number. So I started consulting in 2008, but not through the corporation, but through other companies. And I started realizing slowly that if you spend a lot of time in one corporation, you become like a horse with the blinds. You only see the way the company wants you to see things. And I am a programmer, I love computer science, I love writing code, I love staying up to date with technology. There's so many things happening, so hence the reason for this company to exist. Another thing I want to mention about, since we talked about Manhattan and NYC, it's a privilege to be living in New York City, honestly. In my opinion, because technology is evolving so much. And if you compare the East Coast or New York City to the West Coast, Silicon Valley, there's a lot of, in my opinion, it's a bubble when you go to Silicon Valley. A lot of people create technology that doesn't need to exist sometimes, or is just exploratory. But when you bring that technology to New York, not everybody here is technical. You have finance, you have pharmaceuticals, you have media, you have ag. So you get validated on your ideas here more, which is why I like New York City more, because you find real solutions, or there are real problems that need real solutions, as opposed to just living within your own field. So that's another thing I like about being here. This is a client list that we've done work. A lot of banks, Goldman, Morgan, Credit Suisse, Barclays, City, Hearst, with a lot of apps for Hearst, the guy from Citizen Kane, basically everybody knows that. Verizon, we did some work with pharmaceuticals. So, living in the city again and having a lot of events that we go to, I notice, there's a lot of hype in technology. Bitcoin is a big deal. Blockchain is a big deal. Everybody talks about it as if they're about to split the atom. In AI, I attend a lot of events where I am a programmer. I did study computer science, and I like sci-fi movies, but I separate them in my head. So Blade Runner doesn't bleed into, Star Wars doesn't bleed into reality, because we work with code that really is just numbers and data. And the minute someone crosses the line from software to philosophy and cognition and consciousness, I start thinking, where's the code? How can this work? So the reason I'm saying this is that's why I thought about this talk, is I want to kind of explain to the layman on the street. I'm not saying anybody here is less intelligent, but in your own field, you're separate than our field, but what really AI is, and what kind of projects we see through our work, and how you will see that you don't have to write code. I'm going to open up a typical AI engine and show you internals of it, so that next time when you hear something or think about something, you can realize, how do you think about a project like this? So I'm going to explore the internals of the engine, what kind of projects we have seen through our work. AI is a very sophisticated field. There's a lot of algorithms being written, hundreds of literature, algorithms are being published yearly. So this is not a technical session. You will not come out of here as an AI engineer, to clarify. But you'll be able to understand a little bit more. And because they're so sophisticated, instead of going into slides and just showing you, words and verbs and sentences, I thought I'll give an example of a hypothetical project and how it works. So the talk is going to separate into defining artificial intelligence, which is a broad term. I'm going to jump into machine learning discussion and show you an example through machine learning, which is a big field of AI, and then go to neural networks, which is another field of AI, and then talk about AI in current news. You heard about Watson or AlphaGo and stuff like this. Future trends and how do you think of it from a process perspective as a software system, essentially. All right. So AI is a broad, basically AI is using computers to help us make decisions or predictions about data. And when I say data, I mean large data sets. You have to have a lot of data. And when you have that, you try to find either patterns. So pattern recognition is part of AI. I think you mentioned regular expressions, that could be a primitive form of AI. But finding patterns in the data set and seeing what conclusion you can draw from it. If it's hidden, that means you have randomized data, and you try to see what kind of, is it correlated, is it causated? But that's the overall pattern that we see. What can it do for you in real life? Spam emails. You can use AI for that. If someone's heart has arrhythmia, you could use artificial intelligence to answer questions like that. Brain tumor, CAT scans. Anybody know Roomba, the robot, the floor? That's an implementation of an AI. It just goes around, does one specific task. So it's very cool and very useful. But we have a problem with the word intelligence, because we humans, when we hear the word intelligence, we think about human intelligence, as opposed to computer intelligence. The same way, I don't know if you know about creationism. Creationists say that, theory of evolution is just a theory. So that's why we just say, since it's a theory, I can present my own theory. Although in scientific terms, a theory is a set of reproducible facts. Atomic energy is a theory. Gravity is a theory. You can reproduce it again and again. The word theory doesn't necessarily mean it can be reproduced again and again. So the same way intelligent, I beg to differ whether it should be intelligent the same way we think about human intelligence. Cognizance, self-awareness, and stuff like that. Anyway, I don't want to get too theoretical, so let's get to it. Let's imagine, it's a beautiful time to be alive. A lot of future technologies are being produced. Elon Musk always talks about Mars. So let's say in this hypothetical project that I came up with, we're about to explore Mars. So we're going to get into Martian geology. We're going to send some geologists to explore the surface of Mars first. Now, if someone is a geologist, don't get technical with me. I'm just telling you the terms that I just looked up. Our job is to find whether a Martian rock is volcanic or plutonic. And the definition of a volcanic rock basically is when magma solidifies, when lava solidifies over the planet's surface, it's called volcanic. I'll wait until. All right. And if it's magma, subterranean, it's called plutonic. So that's what we try to find out as we explore Mars. What rocks we encounter, are they plutonic or volcanic? So this decision process is called classification. This is a classical case of artificial intelligence, machine learning. Classification is identifying things, whether it's category A or category B. The system that builds it is called the classifying algorithm. This is a mainstream concept in machine learning. You'll find a lot of companies or banks make a mistake of buying a black box classifier. A classifier built a generic, classifier, as opposed to one built specifically for your needs. So, the good thing about computers and algorithms in general is that we use them to abstract. Abstraction is a famous concept in computer science. You have real world problems, phenomena, objects, so we abstract them using computer systems. In this case, we could have used photos or maybe sounds, but for this specific example, I'm going to abstract the field into features, which are values that usefully characterize things we want to identify and classify. So in our scenario, I'm going to say we're going to look for two features, granularity and density. All right? I don't know, the definition, you could do whatever definition you want for them, and the unit is just a unit. I don't know, you don't have to come up with a specific unit for it. So we sent a geology team to Mars, These guys are top-notch geologists. They walk around, they pick up 200 rocks. Because these guys know their work, they pick up each rock and they label it. They know this is a plutonic rock, this is a volcanic rock. And they write down the granularity and the density of it. This is called training data, or label data. This is very important in artificial intelligence. This data is the data that's used by the algorithms to train the system. So it's your job as the implementer of the AI engine to make sure you have clean training data or label data. And a lot of problems happen because AI doesn't have intelligence the way humans have intelligence. If you give it garbage data, it's going to give you garbage results. An example of this would be, I don't know if you remember, Microsoft had a Twitter handle that was an AI system. And people started tweeting racist and homophobic slurs at it. And within 2 months, within hours, the Twitter handle became racist and homophobic, started answering bad words. Whatever you give it is going to come up with the results of it. So it's your job to give it clean data. It doesn't have its own logic, or the way humans have logic. Unlabeled data is basically a rock that we don't know anything about, somewhere on Mars. So, for the purposes of this discussion, we only have 2 features. So it's kind of easy to plot that on a chart. So here I created a scatter plot. This has 200 points on it. The red ones are volcanic, the blue ones are plutonic. By the way, I want to mention, I don't want to make this like a class. If you have questions, jump in. If I think the question is going to be answered later on, I'll tell you later on. Yeah, go ahead.
So, tell us something about these axes, like why something would
Okay, so
here, right, high or low, or right low.
So the y-axis is density, the x-axis is granularity. The unit can assume whatever unit you want, it doesn't matter that much. But basically this represents all the 200 rocks that the label data, the geologists got to us from Mars. Now if you look at it, there's some randomness in it, but to an extent you have 2 groups that pool together. The reds are kind of to the left, and the blues are to the right. I mean, if you want to look at it a little bit more, some of them overlap. So it's not extremely obvious. How can I separate both between them? How can I divide them? But, and basically, when I said how do I separate, that's one of the mainstream things machine learning algorithms do, find the optimal separation in the data. Now, as a human, because it's just 200 and it's only 2 features, I'm going to eyeball this and say, let's say at 12.5, we should separate the data. So I divide the line. That means I say here, just by looking at it as a guy, as a human, anything below 12.5 most probably is going to be a volcanic rock. 12.5 granularity, let's say. And let's say I want to add one more division. Well, does this make sense to everybody so far or no? Good. Because yeah, please jump in if you have any questions. So let's say we add another division saying if density is less than 0.9, it's gonna be volcanic too. So now the chart has been separated. You can see there's one area which is red with the red hue on it and the blue ones. So real world problems and phenomena will always be messy. The data will always overlap. So the whole idea here is to find the cleanest way to separate between objects or to classify the data. Now, there's no way to draw a line that's going to give you 100% accuracy. That's almost impossible. If you do that, you're going to be very lucky. That means it's a very simple scenario, specifically in machine learning systems. So we have to think about how accurate is the algorithm going to be. Now, based on what I've done here, we could say that we correctly identified maybe 88 volcanic and maybe 78, I forget the numbers, 82 plutonic rocks. Some of the plutonic, the blue ones, fall into the volcanic section. So, but it's very hard for us, there's no other thing we can do if we want to build this algorithm like this. Because if I move this line, the 12.5, up more, I'm adding more plutonic rocks as volcanic. If I lower it, I'm going to lose some of my volcanic rocks. So this is kind of the best optimal solution I found, just as a human looking at it. So there will always be errors. But again, another definition you could think of, and generically speaking, of machine learning algorithms at a high level is maximizing correct classifications while minimizing errors. Max correct, minimum errors. This is called the decision space. this is decision space for, does this have a clicker by the way? No. Decision space for volcanic, and those lines are called decision boundaries. Remember this because we can talk about them later on. So the decision space for volcanic is the one with the red hue. Everything outside of it is plutonic, based on this classification that we gave. So, as I said, machine learning algorithms, they should provide maximum classification with the minimum errors. That's on a very high level. Now, if you could talk to someone who actually is an AI engineer, he might tell you a derivative of this. But to keep this conceptually speaking, that's what you try to do. You have data set, you try to find the maximum correctness of dividing and classifying with least amount of errors. So, based on this training data, we got 107 rocks correct, 30 rocks wrong, for average classification accuracy of 85%. That means if we send a robot to Mars tomorrow and it picks up a rock out of the blue, I'm 85% confident, this is a confidence interval, I'm 85% confident that he's going to classify it properly as plutonic or volcanic. Now if you notice, so the robot on Mars is going to pick up a rock that's unlabeled data. The data that we're going to use for the algorithm to work on. Accuracy varies depending on industry and the project. And AI is extremely context specific. If you notice in the beginning, I called my company a boutique, not an agency or something like this. I didn't do that without thinking about the term. In my humble opinion, again, working with enterprise clients, every project is a specific context. There's no one size fits all. If you want high quality code, if you want a high quality shirt, you don't go to Walmart. You go to like a place where the guy tailors it for you specifically. We see this in multiple variations, in cloud computing, in mobile apps, but not even the most amount of context specific is artificial intelligence. Because there's a lot of big tech giants that provide AI as a platform. But that's too generic. That classifier algorithm has to be built specifically for your need. That means I have to spend a lot of time talking to you and to your machine learning systems architects to find out what are you trying to classify, the details of it, the nuances of it, what features to choose on. So that's why it's very context specific. So, accuracy is very dependent on industry. For example, facial recognition, 99%, 98%. That's very normal to get that accuracy. In finance, I'm sure a lot of people have financial background. Data mining on equity stocks, 55, 60 maximum. Even if you have end of day data since 1970 and you try to build, so instead of Mars and granularity, we could say you could have, I don't know if you guys know what FFO is and EPS, like these technical terms that come from Bloomberg